Plasma cells. The name plasma cell was introduced by the anatomist von Hartz-Waldeyer in 1875. A fully mature plasma cell lacks surface immunoglobulin expression. Plasma cells are characterized by the co-expression of CD138 and CD38. Identification of plasma cells paved the way for the development of monoclonal antibodies. Plasma cells are terminally differentiated B cells that provide specific humoral immunity by secretion of antibodies. In humoral immune responses to vaccines or pathogens, stable protective antibody titers can be detected for decades in serum too. We and others have shown that plasma cells can survive for time periods of presumably years in bone marrow, without DNA synthesis and refractory to signals from antigen or antigen-antibody complexes 3, 4. These long-lived plasma cells are confined to distinct areas in the bone marrow or inflamed tissue and maintain serum antibody concentrations against their antigens. The survival of long-lived plasma cells is dependent on a particular environment of the marrow, which defines a limited number of molecular survival niches, and on the intrinsic capability of a plasma cell to respond to these signals. Although the precise molecular definition of the plasma cell survival niche is still lacking, a number of signals have been identified, which in synergy support plasma cell survival ex vivo, among them IL-5, IL-6, SDF1-alpha, CXCL12, the ligand of CXCR4, and TNF-alpha, 7-9. Obviously, homing of newly generated plasma cells, or their immediate precursors, the plasmablasts, to bone marrow is essential to obtain a stable humoral memory, i.e. stable antibody titers. In addition to the bone marrow, plasma cells are also found in inflamed tissue 10, 11. Although some of them may have been generated within these inflamed tissues, others must have immigrated there, and this immigration is independent of antigenic specificity. Plasma cells comprise less than 1% of cells in normal BM. The morphology of mature plasma cells in Romanowski stain smears varies markedly. Fig. 2.15. The majority are 14–20 micrometers in diameter and have deeply basophilic cytoplasm with a pale paranuclear zone corresponding to the site of the Golgi apparatus. The cytoplasm may have one or more vacuoles. The nucleus is eccentric and small relative to the volume of the cytoplasm and contains moderate amounts of condensed chromatin. A small proportion of normal plasma cells may show various additional cytologic features, such as 1. Russell bodies. Very large, rounded, acidophilic, Pa-positive cytoplasmic inclusions. There is usually only one Russell body per cell. Fig. 2.15b. These result from the condensation of immunoglobulin within distended cisternae of the RER. 2. Mott cells, grape cells, or morular cells, plasma cells containing several smaller, slightly basophilic, rounded inclusions. 3. Flaming cells. Peripheral cytoplasmic eosinophilia. Occasionally the entire cytoplasm may take on an eosinophilic hue. 4. Azurophilic rods with a crystalline ultrastructure, rare, which resemble our rods. These are Pa, Sudan black and MPO negative. Normal plasma cells in the BM are CD19-DIM, CD38++, CD138+++, CD20-, CD45-, CD56-, Sig-, and express cytoplasmic immunoglobulin kappa or lambda 0.55. They are negative for CD45, HLA-DR, CD117 and CD20.